Okay, I see. Can I show this my screen?
Yeah, just a moment.
Mm-hmm. Oh, you did this demonstration. Please provide it for me.
Yeah, I see. I remember.
Sure.
Some people.
Mm-hmm. Hello, guys. Please switch off your mics. Выключите микрофоны, пожалуйста.
Let's start.
Okay. I see. I can start demonstration again. Good. I hope everyone can see my screen, okay?
Yeah, yeah.
The same table. Good. So in principle, using the nonlinear approach and all three coordinates in one formula, we really obtain good precision, even for extrapolation. But still the number of points is 3 or better 4. Why 2 points are insufficient? In fact, it's quite easy to understand. We understand that satellite is affected by a lot of forces, especially tidal forces from moon and sun gravity, and also from solar radiation pressure. It's possible to interpolate this almost constant force using 3 points. It's a quadratic influence, right? With constant acceleration, we have some quadratic influence. But for 2 points, it's not possible to restore such forces. So what is the solution of this problem? And it's very simple. Again, free interpolation is absolutely free in this respect. If classical interpolation cannot do anything, if you want to include other forces in your model, then free interpolation is very easy to modify. So let's go ahead with number of points n equal to 2. And in our previous formula with linear interpolation and with quadratic, cubic, and other higher order terms with respect to coordinates x, y, and z, include positions of sun and moon. So x, y, and z coordinates of sun and moon, or even better, the tidal forces, which are quite common to compute, and it's openly and easily and quite precisely computable, with some unknown coefficients rho x, rho y, and rho z. So we introduce 3 more terms in our free interpolation formula, where we have unknown coefficients alpha, beta, gamma, kappas, and rhos, and certainly epsilon as the error of interpolation. And after training of this new interpolation pattern and new interpolation approach, we obtain the following results. The number of points is still 2, the number which is very physical for any practical application. And with degree 3, 4, and 5, in the next column, I give the previous result when we do not have such extra lunar-solar terms, and with quite good but still insufficient precision of few centimeters. But as soon as we include 3 terms, 3 more terms, 3 more coefficients only, and train our model, and then test on other test cases, then we see that root mean square error is very, very small. And for degree 5, we obtain precision 2 millimeters. Good. So practically speaking, we can see that this simple, well, machine learning or regression or whatever call it approach is quite flexible very precise, and in fact easy to use for any other third party, provided you have a training set. And if someone trains our model and obtains such coefficients alpha, betas, gammas, kappas, and rhos, and communicates, it's just a number of coefficients, constant coefficients, and anyone can use them to obtain the necessary millimeter precise position of satellites between the 2 points without solving any differential equations, formally speaking. On the training stage, we need differential equations to restore trajectories and train our model. But for users, it's not necessary. Good. Also, if we want to restore not only position, but also velocities of our satellites, the same is absolutely possible. And the only thing you need to change in this model of free interpolation is just to substitute here in the left-hand side, instead of x, y, and z, instead of the velocity of satellites, the velocity of satellites. And after training, you obtain precision up to 10 decimal digits. So 1,000th of millimeter per second will be precision of our modeling or restoration of velocities of satellites, which is pretty good. Good. Provided that, let's turn to another point, to another topic of my talk, which is sort of development or a sort of alternative view to the problem oh, someone is hacking us. Who is in? Okay, I see. Certain Ritvik. Oleg, can you switch him off?
Я не знаю. Как... It's your computer.
But I'm not, но я же не управляю всем. Вот тут этого самого.
Ну-ну,
Можно
может быть,
отключить
кто-то залез.
Ну, вот там какой-то присутствует. Риtvik.
Сейчас посмотрим.
Okay, someone is hacking us.
Пробуем дальше. Я отключил.
А нельзя просто-напросто? Дело в том, что
я удалил.
Можно как-то убирать это. А у меня есть.
Нет, я понимаю, как убрать.
Да и как убрать, не знаю. Так, комментарии еще. Включить комментарии участников. Но не помогает. Maybe it's a good idea to restart our Zoom session. Okay, Олег.
А попробуйте просто расшарить, снова скрыть экран, а потом снова расшарить.
Ну да, действительно. Угу. И как это нам скрыть, включить чат-запись? Окей. Good. Все в порядке?
Да, спасибо.
Okay, so solving this interpolation problem, let's turn to the problem of boundary attenuation effect of polynomial filters I talked about in my previous talk 2 weeks ago or 3 weeks ago, yes. Using this methodology, we can overcome this problem very easily. Take free interpolation model, any one, and train them on good trajectories, which have no problems, no jumps, no outliers, no abnormal values. Then use them to find next point and compare to the point given as the input data. If you have some big deviation, then we can see that trajectory is defect. For this, we need at least 2 points, our nonlinear interpolation with moon and sun tidal forces is capable to extrapolate using only 3 points and find the next point, the third point. So boundary effect is no longer a problem as soon as you use this new technology. What is the difference? What's ideologically very different? First, roughly speaking, it's typical for any machine learning technology. Namely, you adapt your model not to some abstract mathematical model or physical model or other model taken from abstract consideration of it, but you adapt your model to real data. And training on good data gives a way to obtain a much better precision and much less problems than the standard technique of interpolation on solving ODEs, etc., etc. So let's move further. We don't have that much time. And as a mathematician, as a researcher, I want to move further and obtain maybe a more generalized approach. If we call our interpolation method free, then, sorry, it's free in coefficients. Now, dependence of coefficients, alphas, betas, gammas, kappas on t hat is absolutely free. It's a free form functions. But still the right-hand side is linear in x plus quadratic terms in x plus etc., etc. So we still have polynomial dependency, not on t bar, not on t hat, but on the input positions of our satellites. Is it possible to generalize? How to get rid of this restriction? For example, can we take, instead of polynomial dependent of x, y, and z in right-hand side, to some abstract, very general, well, smooth functional dependence on all x, y, and z? Here we should understand that I mean that the f has not 4 arguments, but many more. We have n points, 3 coordinates for each, so we have 3n plus 1 arguments for f. At the least 6 coordinates and 1 target point t hat. So is it possible to train somehow our model and obtain an absolutely free form interpolation? Is it possible to do? Okay, let's at least omit the dependence on t hat, as we did. Fix t hat somewhere in between of our interpolation pattern. Then we have a function of 6 arguments at least, x, y, and z in 2 consecutive points with 15 minutes time step. Is it possible to train such a function and obtain it on our big data? At the first sight, that's what we did for our alpha coefficients. We had a number of points from our training set of satellite trajectories we had after solving ODE, right? Number of points is about 1 million. In our experiment, we had about 1 million possible points. And after that, from this 1 million points, we took, using the least squares approach, the best red smooth line. It turned out to be smooth automatically, using this very simple methodology. And the accuracy of such a result is very good. 15 decimal digits will be the precision of our function alpha I of t bar. But this is the case when we have only one parameter, t hat, in our functions alphas. But what about free form function f, when it's no longer linear polynomial on our 6 arguments? Good. Suppose we again have 1 million point in 7-dimensional space. We have 6 parameter x, y, z in one point, x, y, z in another point, and the values of f in the target point. Is it possible to train such a function on 1 million points? Are they enough in 6 dimensions instead of 1 dimension? Alpha is a univariate function, f is 6-variate function. So now we come to the, as I call it, second main problem of real big data. The first problem is just volume of data. megabytes and terabytes, but the second problem, we will see it in a moment. There are too few of them. Million points is not enough. Why? So a very simple geometrical problem. All our satellite trajectories have radius of approximately 25,000 kilometers. So all of them are in a box in the space with 50,000 kilometers size. It's six-dimensional box. We have 2 points, each has 3 coordinates. So we have a six-dimensional cube with the side of 50,000 kilometers. Well, suppose we just splash 1 million points inside such a cube. What will be the distance between them on the average, even for some stochastic distribution of points? The answer is, well, dramatic. The distance will be about 5,000 kilometers in the least. Why? Very easy to compute. Suppose we divide 50,000 kilometers in 10 equal segments, and x of 6 coordinates, 10 to power 6 is just right by million. So in each cube of size 5,000 kilometers, we'll have on the average only 1 point. And we will, if we want to have more points, why 1 million? Let's 10 million, 100 million. It's, well, basically no problem to do such a computation once. But for reference, ladies and gentlemen, unfortunately, we need too many points even to reduce such a distance from 5,000 kilometers from neighboring point to 1 kilometer. Suppose we put 1 point in 1 kilometer at 1 kilometer distance. How many points of them? 50,000 power 6, well, 10 to power 28. Too bad. So in fact, big data in machine learning, that's the second problem of big data and machine learning. Despite the fact that we have a lot of them, there are too few of them. As soon as the number of parameters in our model is 6 or 5 or even 4, what can be done? Good. I don't know the solution of this problem. So a very challenging and interesting problem. How can we understand what should be substituted as a model for really free form interpolation instead of linear, quadratic, and polynomial terms? What kind of general function still doable by machine learning can be obtained? I don't know solution of such problem. So the first topic and the second topic and the third topic of my talk is over. Let's go to some methodological aspects. We have 5 or 10 minutes for that. Let's start, forget about everything, and let's start a quiz for first year student. Good. Suppose we have 2 arrays of usual real numbers, A1 to AN and B1 to BN. What is the name of this combination? Can anyone give me an answer, please?
In a product.
Sorry? Say it again, please.
In a product.
Yes, inner or scalar product of 2 vectors. Good. Any other answer? If you talk to guys in signal processing, they will tell you, okay, this is correlation between two sets of realization of some probabilistic variable. We have a variable A and some realization and stochastic variable B, and this is correlation. Yes, it should be normalized, etc., but it's basically correlation. It's something very different. Good. Next question in our quiz. Suppose we have a matrix, for simplicity, a square matrix with real entries. What is the name of the following matrix? Quite popular in mathematics, right? What is the name of it? People who love geometry would say, okay, we have a basis of vectors in our n-dimensional space, and this is gram matrix of scalar products, right? Because in fact, entries of this product are nothing but such combinations, right? So scalar products, with this matrix, we can compute, for example, volumes, etc., etc. But this is geometric approach. So the name as gram matrix is one possible name. Another possible name also comes in any application when people work with measurements. They say, okay, we know this is correlation matrix because entries are correlations. Okay, so this is also partially true. So naming a formula in mathematics, and it's one of very nice features of mathematics that one and the same formula appear in very different domains, and you can apply technology from one domain to another domain. But is it really important to understand what domain is it when we apply such a formula? Yes, let's go ahead. If we look at the formula 3, anyone who is more or less expert in machine learning and even in classical statistics say that, sorry, gentlemen, but it's nothing new. It's called linear regression. And nonlinear interpolation is nothing but nonlinear regression. It's absolutely not new. It's very well known. And your technology is just standard technology. But in my humble opinion, I would say that in Russian, we know the following very popular saying: "Как вы яхту назовете, так она и поплывет." Naming implies the domain of mathematics you will use to understand, interpret, and finally find accuracy of your result. And the use of term regression in this concept, in my opinion, is wrong because of two reasons. First, trajectories are not random processes. They are very far from being random. And second, what is more important, the method for evaluation of accuracy, and accuracy is the main thing we are after. Such methods are very different for stochastic and non-stochastic interpretation. That's why I would say that interpreting our free interpolation as just linear or non-linear regression will move us to some specific domain which is not really fit for our application, especially for accuracy. And it's not only my opinion. Let's look into classical guys who are real expert in determination of trajectories from measurements. For example, well-known expert Pavel Eliasberg, I'm sorry. He was a person who was the head of section of satellite dynamics in Institute of Space Research in Moscow, responsible for satellites or trajectory of practically all satellites in Soviet Union in all the times. And he published a number of very interesting books on the topic. And please have a look at what he says. That the conclusions obtained using statistical methods that were perfect from mathematical point of view diverge sharply from practical results. Sorry. So in recent years, the team with Eliasberg and other guys in space dynamics in trajectory control of satellites develop another approach, which called it's called differently. Namely, they call it internal convergence. And by the way, what's really very interesting for any mathematician are words of Eliasberg, a practical guy of the very famous epoch in space research. The property of consistence of least squares in practice, as a rule, does not take place. We all teach students least squares estimation, and we say it's the best possible statistical method for evaluation of parameters. And the real guys from experiments, from real engineering applications say, okay, mathematically all this is correct, but in reality, which is much more complicated, this is not absolutely true. Let's take another book by Eliasberg and also his colleague from the same space research division. They published more complicated technology for definition, correction, and estimation of accuracy of satellite trajectories. They say that commonly used in literature probabilistic approach is not really good, and they published a new approach in this book, which is called guaranteeing approach, where they shift from probabilistic approach, and they do not think that probability distributions of data should be considered known. And the result of this guaranteeing approach in some cases are much closer to reality. Good. One more book, even recently I would say, and Belousov also was one of the experts. Unfortunately, we lost him some 10 or 15 years ago, and he said that, sorry, in many real applications, especially in satellite dynamics, in astronomy, in astrophysics, validity of assumption that physical variables has the property of random variables is not obvious. So it's very dangerous sometimes impose statistical or probabilistic approach to your methodologies. That's what I want to say. Okay, let's go to the last topic of my talk, and I will not expose it in details because now we have a published paper on that. The only idea I want to expose is just the idea that it's possible to generalize interpolation to multidimensional case instead of one parametric on time series or one argument functions. We can deal with continuous media, for example, with space or three-dimensional space or continuum media. And in a recent publication, we have developed a method for doing with ionospheric delays in satellite signals. And I'll expose just 2 slides with literature, and the last slide will give the publication when we expose a quite very good extension of our free interpolation framework to modeling modeling ionospheric delays for satellite signal processing. Okay, that's all for now. Thank you very much, and my time is over, and we are open for maybe a few questions.
Thank you.
Thank you.
Спасибо. Вопросы, пожалуйста. Any question? Ну хорошо, я задам такой вопрос. Сергей, а как вот с потребителями-то, они реагируют как-то на эту деятельность или нет?
Ну, как всегда, пока там не расскажешь на десятки конференций, причем специализированных, ну, ничего не трогается с места. Поэтому вот эти доклады, как бы, спасибо за такую возможность продвигать. На самом деле, те публикации, которые есть, они в наших российских пенатах в основном, поэтому надо двигаться. И мы планируем, собственно, в этом году подать парочку-троечку публикаций GPS Solutions, есть такой стандартный журнал. Хороший. Будем двигаться.
Ну, я единственное... Сейчас вот закончится время, мы... Нет, еще 10 минут совершенно спокойно можно разговаривать. Надо только как-то у нас вот, я смотрю, некоторых ученых стали за жабры брать, когда они что-то начинают рассказывать прикладное.
Ну,
ну так.
Почему? Конференций открытых много, потом выкладываются, все мы это докладываем на конференциях. Там рассказывают и намного более забойные вещи про всякие S400.
Ну ладно, ладно.
Ну, как бы так.
Пожалуйста. Искандер хочет что-то спросить? Ладно.
Нет, в планах нет. Это от меня далековато, но интересно.
Ну, спасибо.
Так, еще
Спасибо за доклад.
Ага, спасибо.
Сергей, хотел спросить, а вот какие-нибудь пакеты, оформлены алгоритмы в каких-то программных продуктах ваших?
Да, конечно. Вот недавно, вот в прошлом докладе я рассказывал о статье в архиве, где там есть на GitHub соответствующий пакет, написан на языке Julia. Вот все результаты, которые здесь изложены, они тоже реализованы на Julia, ну и даже там зарегистрированы авторские права. Желающие могут получить. Язык Julia очень мне нравится. Он намного лучше того, что обычно используется. Недавно...
Типа чего? Какая у него функция? Джулия, что он заменяет? Какой предыдущий язык-то?
MATLAB.
MATLAB?
Да. Стандартно для всех инженеров. Но Julia, во-первых, открытый и свободный. Во-вторых, там, поскольку он начал недавно развиваться, нету разных тянущихся издалека, из седой древности проблем во внутренней структуре. Вот, там много хорошего, в общем. И, кстати, Julia в основном нацелена на машинное обучение, вот такие вот большие, обработку больших данных и так далее. То есть это новый язык, скажем так, MATLAB, переведенный в открытый домен и вдобавок еще нацеленный на именно приложение машинного обучения и обработки больших данных.
А как Reduce-то жив? Там какая уже версия свободная? 13-я, 15-я?
Да какая 15?
Почти загнулся.
Да нет.
Ну вот именно, он стал свободным, и все.
Да он и раньше был все, потому что там был последний человек в Германии, который его разрабатывал. И привет. Ну, вдобавок, компьютерная алгебра, она не очень...
Он все еще работает. Я встречал где-то лет 5 назад. Они пытались на новые системы ввести это. Reduce.
Нет, конечно, там есть кое-какие подвижки. Вы можете их сейчас хоть на телефоне Reduce пользоваться.
Да я пробовал, запускал, кстати, на планшете. Отлично работает. Только зачем?
Я видел. Да, то есть простые вещи так вот на природе можно делать на нем.
Просто компьютерная алгебра сама довольно-таки узкая область, если посмотреть по приложениям.
Вот. А ну, вот по крайней мере, в тех книжках, которые написаны, это так. На самом деле она могла бы там... То есть аппарата больше, чем вот излагается в стандартных книжках.
Сережа, а ты не можешь спел Джулия, как спеллинг?
Сейчас, секундочку.
Сережа, а там же в этом в Википедию про Джулию хорошо написано.
Да, просто я сейчас скину ссылочку.
Да, есть это. Это достаточно. Несколько вот последних лет модно стало Джулией пользоваться.
Вот. Julia, Programming Language.
Не
Кстати,
видно.
А интерфейс у него хороший?
Смотрите, это вопрос
Или
хороший.
все с командной строки, как в Reduce?
Что же, как в Reduce? Можно и к Reduce прикрутить интерфейс. Я использую стандартные программистские, эти, как назвать так, редакторы. Ну, в частности, Visual Studio Code. Он тоже открытый, удобный. Julia поддерживает его. Там есть свои собственные интерфейсы, там, с отладкой и прочим. Но на таком уровне просто не надо. Скажем так, серьезные люди все равно с командной строки все запускают для серьезных приложений. А процедуры написания, отладки, поддержки там программных конструкторов, там спелл-чекинг, все это есть у программистских редакторов. Это сейчас вообще разделяется и правильно делается, должен сказать. Вот. Это как латех. Виноват. Ты пишешь в редакторе, а потом запускаешь, верно? Конечно, есть там разные интегрированные среды, но они, как правило, частично ублюдочные. Так или иначе. Так, спасибо.
Так, пожалуйста, еще вопросы. Погромче. Вопросы еще, пожалуйста.
Не слышно. Не слышу вопросов. А запись-то была включена, я забыл.
Конечно, Сережа, вон, все идет.
Но у меня почему-то нету этого.
Ну, хорошо. Ну, ладно тогда. Значит, следующий раз предполагается Шмидт Алексей.
Сначала надо поблагодарить докладчика за интересное сообщение.
Ага, да.
Спасибо слушателям. Учитывая, что перерыв, что почти все дожили до конца. Спасибо за внимание.
Ага. Я еще раз приглашаю всех поактивнее участвовать, да, и задавать вопросы, и самим что-то рассказать. Москва у нас как-то пассивно принимает участие. Давайте, пишите, пожалуйста, свои предложения по докладам на
С
почту.
удовольствием послушаем, что там механические приложения. Саша Аксенов,
Да.
может быть, что-то расскажешь?
Сереж, думаем.
Ага, давай.
Думаю. Ну и я думаю, там молодежь вот какая-то появляется. Можно было бы их с удовольствием послушать, да?
Возможно.
Мгм. Ну, сегодня такая специфическая тема, может быть, там, поэтому немножко народу было меньше, да? Но я считаю, доклад хороший был, такое изложение достаточно ясное было. Хорошо, спасибо, Сережа.
Да, спасибо. Пришлю презентацию, то есть слайды, чтобы выложить на странице. Ну и видеозапись жду в каком-то виде, чтобы ее тоже предоставить через портал Research Seminars.org.
Мгм. Ну, все, тогда всем спасибо. До
Спасибо.
свидания.
До
До
свидания.
свидания.